Hey guys, this is lesson 1.7. It's the video lesson, and this is ratio and rate problems. So you should be watching this if you are absent or if you want extra practice. Also, remember to follow all directions in this video. So if I tell you to pause, etc. And you can pause it and rewind out whenever you want. If I go too fast, just pause it and write something down. So we're going to start by going over some examples to show you what we're doing here. So we're going to start and we're going to read this problem here. It says Heritage Middle School has 150 students. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. All right, so here's what we're going to do. First, I want you to cross off method 1 using a bar diagram. Now, this is what we did in the inquiry lab yesterday, where we helped see it, and we can talk about that in a little bit, but we are going to be focusing on using equivalent fractions. So if you kind of go like this, you're not going to really be doing this on a test, even though you could. We're going to be doing method 2. Now, here's something I want you to watch. I'm going to kind of box out what the book already has here. So I'm going to just draw a box over these methods. So you can see, now remember, I am doing method 2. So I just want you to watch how the problem comes about. So I'm going to get it set up real quick. So I just wrote this down. Over here, you'll see I have a rate you know. You don't have to write this, just watch. What you need to find out is going to go over here, and I have my equal sign. So I'm going to go through, and I'm going to circle some stuff we know in the problem. First off, in the problem, we know the Heritage Middle School has 150 students, right? And we know 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students will prefer, and the whole school will prefer gel toothpaste. So that's what we have to find out. So we have to predict how many students in the entire middle school prefer gel toothpaste. So I'm going to start with the rate we already know, and it's right here in the problem. 2 out of 3, that's the rate we know. They are the students in Mrs. Mason's class who prefer gel toothpaste. So I'm going to write that, I need the pencil on, sorry about that. I'm going to write that down here. 2 out of 3 total students prefer gel toothpaste. Now, if we have that rate, and we also know there's 150 students in the middle school, we can figure out the answer to this question. So remember, it says how many students in the whole middle school prefer gel toothpaste. Well, if the whole middle school has 150 students, we want the 150 down here in the denominator, because that's the whole amount, the whole middle school. All right, so this is basically what we have to do. If we know, once we have these 3 pieces of information, we can figure out our answer, which is going to be there. So we're going to use this by multiplying or dividing. So I start by knowing I know 3 times 50 is 150. Now let's pretend I didn't know that in my head. How would you figure out 3 times 50 is 150? Well, all you would do is you would use inverse operation. So you would take this 150 and divide by 3. If you do 150 divided by 3, you get 50. So, but you might just know 3 times 50 is 150. Now, if you know that, you go up here and you do 2 times 50. Yeah, always do, these are always the same thing. And you get 100. So that means, it says how many students in the entire middle school prefer gel toothpaste? 100 students would prefer gel toothpaste. Now I'm going to delete this box so you can kind of see right here. Likes gel, total, 150 total. And this box here is like what we had. They multiplied by 50, so 100 students would prefer gel toothpaste. All right, now in example 2, it's going to be another problem. And again, they have method 1 with the bar diagram, and on the top of the next page, go back over here, you just need to watch, and I'm going to draw another box to block it out so you can watch me solve it. Now this time, as I go through, I want you, oops, I messed up there. I want you to watch as we circle what we know and underline what we need to find out, and we're going to set up equal ratios. So let's start by reading this problem here together. It says, the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. So that's going to be the rate or ratio we know. Lucas sent 18 text messages. How many text messages did his sister send? That's what we need to find out. How many text messages did his sister send? And we also know Lucas sent 18 text messages. Remember, that's Lucas right there. So I'm going to put a little L. All right, so first off, we have to write that ratio we know first, which is 3 to 4. But it's going to be very important to label what the 3 is and what the 4 is, because that's going to help us know where we put our 18. So watch when I go back in the problem. I want to figure out who has the 3, who has the 4. So I'm going to switch to blue, and I'm going to read the first sentence again. The ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister. So what comes first in that sentence? So the first thing is the text messages sent by Lucas to the number of text messages sent by his sister. So notice Lucas's text messages is first. So that means this 3 is Lucas. And that means the 4 is his sister. So I just use an L for Lucas and the S for his sister. Yes, you need to label those. Otherwise, you're going to put the 18 in the wrong spot. Now, we're going to set this up as an equal ratio. And we have to figure out where this 18 goes. The question is it Lucas's or his sister's 18 messages? The problem will tell us. This says Lucas sent 18 text messages. Remember, I wrote that little L there. So that 18 belongs to Lucas, which means we have to put the 18 on top next to his 3. And the question says, how many text messages did his sister send? Well, that's going to be right here, because remember, for every 3 Lucas sends, 4 his sister sends. All right, so now we're going to do some multiplication. I know 3 times 6 is 18. And remember, if you didn't know that, you would use inverse operations and do 18 divided by 3, and you would get 6. So 3 times 6 is 18. So I do 4 times 6. You always have to multiply by the same thing, and I get 24. So that means if Lucas sent 18 messages, his sister, this is the answer, sent 24 messages. That is the answer to this problem. They're the examples, and this is what we're doing and what you are. They have method 2, using equivalent fractions. Remember, that's what we're going to be doing. So let me be trying in a second on this page. So I am going to, if you're on page 73, I'm going to help you a little bit through A, step by step. So you're going to have to follow my directions. And after we're done with A, you are going to do B by yourself and then check it with the video. So let's start. First thing, as I read A, we're going to go and circle what we know and underline what we have to find out. Are you ready? It says, in a survey, 4 out of 5 people preferred creamy over chunky peanut butter. This is what we know. That is our rate, our ratio. 4 out of 5 prefer creamy over chunky. Okay? Now, there are 120 people shopping at the grocery store. So this 120 people are the ones shopping at the grocery store. They're the total people. Use the survey to predict how many people in the store would prefer creamy peanut butter. Okay, so we are going to start, and we're going to be doing it over in your green space on the right. So we actually have some room. Why don't we do it down here where you have some room? All right, so I want you to follow my directions here. First thing I want you to do is you are going to write down here the ratio that you already know. Remember, you'll have a number on top and a number on bottom. Look in the problem. What do we already know? Okay, did you write it? You should have 4 out of 5. Now remember, 4 out of 5 prefer creamy over chunky. So the 4 out of 5 prefer creamy. And out of 5, that's out of 5 total, right? So I could either, you know what I'm going to do to shorten that, because I don't like to have a lot of messiness here. I'm actually going to, I'm just going to write the 4, I'm going to put a C for creamy, and the 5 is out of the 5 total people you ask. All right, now, what do you do with that 120? The question is, do you put the 120 on top with the creamy, or the 120 on bottom with the total? I want you to think where you're going to put it. So the question is that total people, or is that people who prefer creamy? Think about it. Okay. says there are 120 people shopping at the grocery store. That would be 120 total people. That has to go on the bottom with the total. Now, here's what you're going to find out. This is where your answer is going to go right here. Remember the question says, we squiggly underlined it, how many people in the store would prefer creamy peanut butter? Remember, creamy is on top. How many people would prefer creamy? It's got to be on top. So here's your job. Your job is to figure out what you do to 5 to get 120. Do the same thing to 4 to get your answer, and write your answer on the A line. Now remember, if you don't know 5 times what is 120, do 120 divided by 5 to figure out that number. All right, I want you to try this one. I want you to pause the video, and I want you to try getting this answer. Write it here. When you're done, restart it. Go. Okay, let's see how you did. So, did you figure out 5 times what is 120? Well, if you do 120 divided by 5, you should get 24. So 5 times 24 is 120, right? Now, to get your answer, you do 4 times 24. Okay, did you do that? Because if you do, you should have 96, which is our answer. So we're going to label it 96 prefer creamy. If you said 96 people, that's fine. So that's how we do it. Now, here is your job. Your job is to do problem B completely on your own. You have lots of room to work with it down here or here or here or wherever. So you're going to write the ratio you know, put the other number either top or bottom, but you got to match it up. That's why we label it creamy total. And then put your answer on the B line. Let's see if you can do B by yourself. Pause the video. When you're done, restart and see what you did. Go. Okay, let's see how you did. So, first off, here's what I know. A survey found that 12 out of 15 people in the United States prefer eating at a restaurant over cooking at home. So they prefer eating at a restaurant. Now, I'm actually going to write that down here. So 12 out of 15 prefer eating at a restaurant. So I'm going to write R for restaurant, just so I know that's who goes on top. And that's out of 15 total people. So I write T for total. Now, let me continue. If 400 people selected eating at a restaurant on the survey, how many people took the survey? Well, where did you put that 400? Notice it says if 400 people selected eating at a restaurant. So that means the 400 should be on top next to the eating at a restaurant. And the question says, how many people took the survey? Well, that's how many total people. So we don't know that. That is going to be our answer. All right, so let me get ready here. First off, I have no idea 12 times what is 400. Okay? I have no idea. So what I need to do is do 400 divided by 12. All right, so I'm going to do 400 divided by 12. And I get 33.3. Oh, this one's going to be tricky. All right, so now keep that 33.3 on your screen. So it's 30 times 33 point, notice the 3 goes all the way across. Okay, now, if you hit clear, you're going to have to do 400 divided by 12 again to get that 30. And don't clear that 33.33333 from your calculator. Because once you have it, since we know we're going to multiply 15 times 33 times that number, just, if you have it on your screen, just do that number, hit times 15, and you should get 500 total. So your answer is going to be 500 total people. All right? Okay, so that's it for that problem. All right, for example 3, we're actually not going to do this double number line because that's really confusing. But I'm just going to show you kind of like what we were doing and give you one more example, but show you something if you run into a certain problem you may need to do. So for this one, you could just watch and leave yourself notes, but make sure you cross out that double number line. I don't want you doing that because it's kind of crazy. All right, so let me put a box over this stuff so I can do some work and you guys can see it. Okay. So this problem says the Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So I'm going to start by writing the rate I know. So they drove 105 miles. Oops. 105, always label it, even if it's just a letter or two, on 4 gallons of gas, 4G. And it says at this rate, how many miles can they drive on 6 gallons of gas? So that 6 gallons has to be on the bottom. And we are going to figure out how many miles right there. That's going to be our answer. So I'm going to put a box. Now, if you're looking at this and you're like, wait, 4 doesn't go into 6. Yes, you can divide 6 by 4 to get that decimal number. But let me show you a different way to do this. And this is going to be kind of like the inquiry lab yesterday, where we first found the unit rate by dividing, and then we multiplied to get 6. So watch what I'm going to do. So I'm actually going to erase this here. So I'm going to figure out the unit rate, because honestly, guys, the unit rate is really easy to figure out for any problem. You just have to divide by whatever the denominator is. 4 divided by 4 gets you 1, right? And then you do 105 divided by 4. And yes, you could use a calculator. So I'm going to type in 105 divided by 4, and you get 26.25. Okay, so here's what we did. We found the unit rate, and I'm going to highlight this unit rate in yellow right here, 26.25 in 1 gallon. So remember that there. Now, once you get that unit rate, we can then multiply to get our answer. Because remember, we have to figure out how far will they drive on 6 gallons of gas. So you just do 1 times 6. And you do 26.25 times 6. And if you do that, you get 6 gallons on the bottom, because 1.6 is 6. And on the top, you have 26.25 times 6. And you get 157.5 miles in 6 gallons. And that is your answer. Okay, so again, here's what we did. We started by dividing by the denominator here, the 4 divided by 4, and got us our unit rate. So we figured out in 26.25 in 1 gallon. And then once we had that 1, because 1s are easy to deal with, we multiplied it by 6 to get 6 gallons, and we multiplied 26.25 by 6. So that's kind of what you're going to have to do in problem C. So we're going to set it up. I'll kind of set it up. I want you to write down what I have, and then I'm going to let you finish it. So let's get started here. It says there are 810 calories and 3 scoops of vanilla ice cream. So we're going to write that down here. 810, C for calories, and 3, S for scoops. Okay? The question says, how many calories are there in 7 scoops of ice cream? So you know you're going to have to figure out in 7 scoops. Now here's the problem. 3 does not go into 7. So this is what you are going to do. So let me erase this, and you can erase this too if you already wrote. Erase that 7. Because you are first going to find the unit rate right here. And that's going to be how many calories are in 1 scoop. And that should be easy, okay? Because you're going to do something from the 3 to the 1. Once you get your unit rate, you're going to take your unit rate, and you should be able to figure out how many calories are in 7 scoops. All right? So I'd like you to pause it. Remember, figure out the unit rate here. Once you get the unit rate, you should be able to figure out 7 scoops here, which is going to be your answer. So pause it, try it, restart the video, see if you're right. If you're totally lost, you can do it with me, but you're not going to get as much out of it if you don't try it first. All right, go ahead, pause now, restart when you're ready. Okay, so you're ready for the unit rate. So remember, to get the unit rate, it's easy. Just whatever the denominator is 3, you divide by it. 3 divided by 3 gets you 1. And then you do 810 divided by 3. And you should get 270. So there's 270 calories in 1 scoop. That is your unit rate, and that makes the rest of the problem easier. So find the unit rate first, and now to go from 1 scoop to 7 scoop, it's just times 7. And then you're going to do 270 times 7, and I'm going to type that in. So 270 times 7 is 1890, or 1,890 calories. So the question said, how many calories are there in 7 scoops? On your answer line, you should have 1,890 calories. That's it. All right. Next page, we have one more we are going to do. We're going to do example 4. They have it done again for you. And then you'll do problem 6 on your own. But in example 4, I'm going to again box out. Let me draw a box over all this because I want you to see how those numbers come. You have it in your book so you don't have to write anything down unless you want to. All right, first, it says Jeremy drove his motorcycle 120 miles in 3 hours. So 120 miles, 3 hours. Always start by writing your rate as a fraction. Easy. At this rate, how many miles can he drive in 5 hours? And this will be where our answer goes. But here's the problem. 3 doesn't go into 5. If it did, easy, this one would be done. Since it didn't, I'm going to do it like in that last example. I'm going to find the unit rate first. And then I'm going to figure out 5 hours. Remember, finding the unit rate. Divide by whatever the denominator is. In this case, it's 3, and 120 divided by 3. That will get me 40 miles in 1 hour. Now, I'm going to figure out 5 hours. Okay, so 1 times 5 will get me my 5 hours, and 40 times 5 will get me 200 miles, which is my answer. Okay, and we'll show you down here just so you can see that's exactly what they did. 120 miles in 3 hours, they divided by 3 to get their unit rate, which is 40 miles per hour. And 40 miles per hour times 5 is 200 miles. So that's all. All right, are you ready? I really want you to do problem D completely on your own. If you have to, you might have to find the unit rate first, but maybe you won't. Maybe you won't have to do that. So try D. Pause the video. When you're done, restart it. See if you got it. Go. Pause it now. All right, so here's what you should have. I'm going to go over it. It says, while resting, a human takes in 5 liters of air in 30 seconds. So I'm going to write that down. 5 L for liters, 30 seconds. Remember, that's your rate. At this rate, how many liters of air does he take in during 150 seconds? So 150 seconds goes down here. Now, you can find the unit rate first, but you don't have to in this. You know why? Because 30 goes into 150. 30 times 5 is 150. So then I don't have to find the unit rate. That one's an easy one. 5 times 5 is 25. So that means, at this rate, how many liters of air does it take in 150 seconds? 25 liters of air. If you got that, give yourself a C, because then you know what you're doing. All right, you're done with me, but at any time, if you're doing practice problems, like if you're absent, you might have to do some problems down here. Look on your absence sheet to see. Rewind the video back and see. Like if it says example 1 here, if you have trouble with it, rewind until I go over example 1. All right? That's it. Hope I helped. Later.